All right, I'm going to go ahead and do a quick demonstration of how you're going to calculate your concentration of ions, okay? So there's a couple of formulas that we need. One to note is that when you have your pH and you add it to your pOH, that's going to equal to 14. And the reason for that is if we look at our pH scale, okay, so our most acidic is 1 and our most basic is 14. And so essentially what that means, I have this table here. So you can see right here, okay, so right here where I have that very low pH, so even a pH of 0, which I can't even measure on my little paper, I can see that I have a huge percentage of hydrogen ions. That's what pH means. pH is percent of hydrogen ions, or the concentration of hydrogen ions. So when you see these little brackets, that means concentration. The higher the concentration, the lower the pH. On the other hand, I have these hydroxide ions. Okay, so if I'm looking at the pOH, okay, percent hydroxide ions, that's the concentration I have of these OH ions. So you could see right here, the higher concentration of OH ions I have, the more basic it is. Okay, so if I'm measuring in pOH, then the scale is flipped. Then that means that down here, I'm going to have a pOH of 14, and over here would be a pOH of 0. Okay, so this is going to be flipped around. So let's go ahead and do a practice problem. The other set of formulas you're going to need are on your lab. So I have pH, which could be either negative log, the concentration of your hydrogen ions, or if you're trying to figure out the concentration of your hydrogen ions like you would right here, for your calculated hydrogen ions, you're going to use 10 and then your exponent of your negative pH. Okay, and so this is the formula. These two right here are actually the formulas I'm going to use. So first off, okay, so let's say that I measure something that has a pH of, let's say, 2. I'm just making this up. Okay, so using my formula, then I know that my pOH is going to equal 12, okay, because these two numbers right here have to equal 14 because that's what's on my scale. So if I need to figure out my calculated hydrogen ions, okay, so calculated concentration of hydrogen ions, okay, so remember this right here means concentration. Okay, so if I need to do that, I'm going to use my formula, concentration of hydrogen ions equals 10 to the negative pH. So I have my pH right here. I have my pH of 2. So I'm just going to substitute that in. This is equal to 10 to the negative 2. So I'm going to use my calculator. 10, let's see here. Okay, so I get hydrogen concentration of 0.01. Okay, so this is going to be the concentration of my hydrogen ions. If I want to do the same thing with my OH ions, okay, concentration of that equals 10 to the negative pOH. Okay, so I have my percent OH right here is a 12. Okay, so I'm going to do 10 to the negative 12. Let's see what I get. Okay, so my calculator's kind of small, so it doesn't want to do this. So I get 1 times 10 to the negative 12. Okay, so if I wanted to count this out, that's going to be a lot of zeros. I think it's going to be 11 zeros. 1, 2, 3, 4, 5, 6, 9, 10, 11. Okay, that's what it's going to equal to. Okay, so this is how you're going to calculate your concentrations of hydrogen ions and your OH ions. Okay, so let me know if you have any questions.